So today we will start. In the last class we discussed all about LCM, ठीक है? Least common multiple. And today we will discuss prime numbers. A positive integer p greater than 1 is called a prime number if plus minus 1 and plus minus p are only its divisor. Here this number is very common to all. Okay, we know this number. What is the prime number? All other positive integers greater than 1 are said to be composite numbers. Okay, those who are not primes are called composite number. The first few primes are 2, 3, 5, 7, 11, 13, 17, 19, 23 days. Okay. So the integer 2 is the only even prime. All other primes are okay. All other primes are odd, but only 2 is the even prime. Any divisor of an integer n, which is a prime, is called a prime divisor of n. Now, the lemma 1 small result, this one, every integer n greater than 1 has at least one prime divisor. Okay. इसका और भी फॉर्म इसे ऐसे भी कह सकते हैं, the smallest divisor of a composite number is prime. The smallest divisor of a composite number is prime. Let d greater than 1 be the least positive divisor of n. If d is prime, then we are done. If not, then d is a composite number. Okay, d prime नहीं है तो d composite number. So composite number can be written as d equal to some d1 into d2. Means इसका कोई दो फैक्टर है हमारे पास at least. Okay, so this is equal to d1 into d2. And d1, d2 are conditions to this. 1 less than equal to d1 strictly less than d, and 1 strictly less than d2 and strictly less than d. मतलब d1, d2 lies between 1 and d. So this implies now by assumption d divides n, because d is a divisor. We are considering d positive divisor of n. Okay, so d divides n by assumption, and d1 divides d and d1 divides d. So combining these two, d1 divides d and d divides n, means d1 divides n. Okay, but d1 less than d, but d1 less than d, and d is the least divisor of n. Okay, we take least positive divisor, but here we have found here d1 is a divisor of n, and also d1 condition, d1 के साथ condition ये है कि d1 less than d. So इसका मतलब d से भी और small number जो है वो इनको divides n. Okay, which is not possible because d is the smallest divisor of n. Okay, but here we are getting a number which is less than d but d less than d but divides n, which is not possible. So this is a contradiction. Therefore, d is prime, because we take, on the contrary, we take d not prime. So we get a contradiction. Hence, d must be prime. So it is proved that the smallest divisor of a composite number is prime. कोई भी नंबर हो, ठीक है, स्मॉलेस्ट ऑफ ए कंपोजिट, कोई भी कंपोजिट नंबर हो, उसका जो डिवाइजर है, स्मॉलेस्ट डिवाइजर, इट विल बी ए प्राइम नंबर. Now lemma 2, if p is a prime number and if p divides mn, then either p divides m or p divides n. If p divides product of two numbers, okay, then either p divides m or p divides n. So if p divides m, then we are done. Okay. Suppose p does not divide m, then by definition of prime, GCD of pm equal to 1. Okay. Since these two numbers, p is not divided m. Okay. So GCD of pm equal to 1. Then by using theorem, there exist integers x and y such that 1 can be written as, because GCD 1 and GCD can be written always as a combination of these two numbers, px plus my. Okay, for some x and y are in z. Okay. So now multiply by n, pxn plus myn equal to n. Since p divides mn, So therefore Mn equal to some Pk. Okay. It is given to us P divides Mn. So therefore Mn equal to P into some K for some K in I. Okay. So then 1 implies Mn replaced by Pk. So Pxn plus Pky, Mn replaced by this Pk. Pky equal to N. So P, here P is a common. Xn plus Ky, X integer, N integer, K integer, Y integer, all combining this is an integer. So P into some integer equal to N. This implies P divides N, means P is a factor of N. Okay. So if P divides N, then we are done. If P not divides N, then P must divides N. Okay. Now this is a small theorem. This is called Euclid's theorem. There is an infinity of primes. मतलब primes कोई ऐसा नहीं है कि 10 है, 20 है, 30 इतना नंबर से या 1,00,000 है. कोई प्राइम अनलिमिटेड इंफिनिटी ऑफ प्राइम्स है. देयर आर इंफिनिटी ऑफ प्राइम्स. कोई कमी नहीं है प्राइम्स की. जितना आप जो नंबर है उससे बड़ा एक नंबर प्राइम आपको मिल जाएगा. ओके. तो कहीं खत्म नहीं है कि प्राइम नंबर यहाँ तक है, इतना ही है प्राइम नंबर. ओके. सो देयर आर infinite. Infinity of prime means infinite number of primes. Primes कोई counted वो नहीं. So let on the contrary that there are finite number of primes. Okay, आपको prove करना है there are infinity of prime. You take on the contrary that there are finite number of primes. Then there exists a positive integer n such that the prime numbers be p1, p2, pn. Let p1 less than p2 less than pn. Okay. So now consider the an integer n equal to p1, p2 up to pn plus 1. If p1 greater than equal to 2, clearly n greater than t, n greater than equal to 3. Okay. N greater than pn and clearly n greater than pn. Okay, because this is the product p1, p2, pn and plus 1. So n strictly greater than pn. So this. Now, if n is prime, since n greater than pn, if n is prime, since n greater than pn, it shows that there exists a prime which is greater than pn. Okay, if n greater than prime, if n is prime, since n greater than pn, it shows that there exists a prime which is greater than pn. Okay. Suppose n is not prime. Suppose n is not prime, that is composite number. Then it is not divisible by it. Then it is not. That is composite number. Then it is not divisible by any primes pi, pi1 equal to n. As such a division, leave 1 as the remainder. Okay. कोई भी p1 p2 से divide नहीं होगा. Otherwise, you will get remainder 1. This shows that if n is composite, it must be divisible by a prime greater than pn. Okay. So this shows that if n is composite number, it must be divisible by a prime greater than pn. हम जानते हैं क्या है, कोई भी composite number है. अभी जो लेमा आपने क्या इसमें कि कोई भी composite number है, उसे उसका जो smallest divisor है वो prime. ओके. तो कंपोजिट नंबर को हम प्राइम से डिवाइड करेंगे. इसका मतलब ये सबसे डिवाइड तो नहीं हो रहा, p1 p2 pn तक. इसका मतलब pn plus 1 कोई प्राइम है जो इसे डिवाइड कर रहा है. ओके. सो इट मस्ट बी डिविजिबल बाय ए प्राइम ग्रेटर देन pn. Thus in either case there exists a prime greater than pn, but this contradicts our hypothesis that there are only finite primes. Hence there are infinitely many primes. Okay. So दोनों केस में हमने ये देखा. ओके. दोनों केस में हमने ये देखा कि इससे वी आर गेटिंग ए लार्जर प्राइम देन pn. हमने अप टू pn तक लिया, p1 p2 pn, लेकिन वी आर गेटिंग अनदर प्राइम. इससे there we find okay. So which is a contradiction. So therefore on the contrary, we suppose that there are finite number of primes, which is wrong. Means there are infinity of primes. Now theorem: if p1, p2, P comma P1 comma P2 up to Pn all are primes, and if P divides P1 P2 Pn, then P equal to Pi for some I. If P comma P1 comma P2 comma Pn all are primes, and if P divides P1 P2 Pn, then P equal to Pi for some I equal for some I 1 less than equal to n. इसका मतलब P इनमें से किसी एक के बराबर, ठीक है. If P divide this product P1 P2 Pn, so then P must be equal to sum of the Pi. कोई होगा मान लो P5 P6, P इक्वल टू P5 हो सकता है, P इक्वल टू P4 हो सकता है, किसी एक Pi के बराबर. भाई लेमा 2 P divides P1 or P divides this product. Okay. Again by lemma 2 P divides P2 or P divides this. Thus by a finite number of applications, एक के बाद एक आप फिर प्रोडक्ट में लगाइए. कोई तो दो पार्ट में कर लीजिए. जिससे सबसे ये P divides this, तो इसको P1 into this कर लीजिए, P2 से आगे तो दो पार्ट कर लीजिए. सो जो आइदर डिवाइड्स m और डिवाइड्स n, तो ये आपका P2 से लेके ये n हो गया, ये n और ये n, तो P डिवाइड्स P1 और P डिवाइड्स P2 n. अगेन बाय इसमें फिर लगाइए P2 यूज उसी लेमा. ओके. P डिवाइड्स P2 इनटू दिस, P3 से आगे n और P2 मान लीजिए सपोज m, तो P डिवाइड्स P2 और P. So thus by a finite number of applications of lemma 2, we deduce that P divides Pi for some I. तो see, since P and Pi are primes, okay, दो प्राइम कब एक दूसरे को डिवाइड, कभी एक प्राइम दूसरे प्राइम को डिवाइड will not divide. Okay, a prime will not divide other prime except itself. Okay, तो इसका मतलब कोई ना कोई P divides Pi for some I, इनमें से ये सारे मिलाएंगे तो कहीं ना कहीं P divides some P. Okay, so उस वो जो Pi है कोई सा भी हो, वो एक Pi या P के बराबर है, अदरवाइज आप डिवाइड नहीं करते. ओके, बट यू आर गेटिंग डिवीजन, सो P इक्वल टू Pi फॉर सम. नाउ प्रूव और डिस्प्रूव इफ P इज प्राइम. ये दोनों जैसे होम असाइनमेंट देख लीजिए. इफ P डिवाइड्स A and P divides A square plus 6B square, then P divides B. If P divides A and P divides A square plus B square, then P divides B. तो प्रूव स्मॉल रिजल्ट से अपनी तरफ से ट्राई कर लीजिए. ना हो तो मैं बता दूंगा नेक्स्ट क्लास. Okay, so if P and Q are twin primes, then show that PQ plus 1 is a perfect square. Since P and Q are twin primes, then P minus Q equal to 2. Twin primes इसे कहते हैं कि दो प्राइम्स के डिफरेंस 2 होना चाहिए. Okay, Q minus P जो है वो 2 होना चाहिए. सपोज Q बड़ा है PQ, P है Q, so इन दोनों डिफरेंस 2 होना चाहिए, उसे ट्विन्स प्राइम्स कहते हैं. So this is equal to P minus Q equal to 2. Okay, difference between these two is 2. जो भी बड़ा प्राइम है, बड़ा प्राइम से छोटा प्राइम माइनस करिए, then you will get 2. So these two such two primes are called twin primes. So P minus Q equal to 2. This implies P equal to Q plus 2. So now PQ plus 1, इस क्वांटिटी को आपको शो करना है, it is a perfect square. Okay, so PQ plus 1 equal to P बराबर Q plus 2 here. Q plus 2 into Q plus 1, that is Q square plus 2Q plus 1. This is implies equal to Q plus 1. Where Q is an integer plus 1 again an integer square. So which is a perfect square. Okay, PQ plus 1 becomes Q plus 1 whole square. That means it is a perfect square. Prove that for each prime P greater than equal to 5, P square plus 2 is a composite number. Since P is a prime number, it must be of the form 3k plus 1 or 3k plus 2, where k is a positive integer. Okay, these two number will give you all primes. Okay, primes के जो forms है वो either 3q plus 1 or 3k plus 2. So case 1, when P equal to 3k plus 1, then P square plus 2 is a composite number. Okay, so when P equal to 3k plus 1, these are the only two possibilities of primes. Either this will give you prime or this will give you prime. Okay, where k is a positive integer. You can check it. This will give. So when p equal to 3k plus 1, then p square plus 2 becomes 3k plus 1 whole square plus 2 equal to this calculation of, or expanding this and this is equal to 3 times of this. Okay. See, this is an integer. So product of two integers is, so p square plus 2 becomes product of two integers. Therefore, this is a composite number. This p square plus 2 is a composite number. Now, suppose k is equal to case 2 when p equal to 3k plus 2. Then p square plus 2 equal to 3k plus 2 whole square plus 2. This after calculation. This is equal to 3 into 3k square plus 4k plus 2. This is again a composite. So p square plus 2 is a composite number for all p greater than equal to 5. Remark for p equal to 3, you see p square plus 2 equal to 9 plus 2 equal to 11. This is a prime number, which is not, see, p square plus 2 is not a composite number, you see, for p equal to 3. So it is a restriction is p greater than equal to 5. If p and q are twins prime, then show that 12 divides p plus q where whenever p is strictly greater than 3. Okay. So you see, let q equal to p plus 2 means p minus q equal to 2. So q equal to p plus 2. P minus 2 or q minus 2. This is, we generally take q minus 2 equal to p means q equal to p plus 2. So then p plus q equal to p plus q, p, q is p plus 2. So 2p plus 2. This is 2 times of p plus 1. Okay. So p is a prime. Okay. Primes of this form 3k plus 2 suppose. So 3k plus this, because 6 times of k plus 1 equal to 6 into 2n. Okay. You see here 3k plus 2 means k odd. In last example, you see, whenever you take this becomes a prime, you have to put k as a odd. Okay. And when you are taking 3k plus 1, then you have to put k even. Okay. So here we are taking 3k plus 2 means we are taking k as a odd for getting our prime. Okay. ये number जो है, this is a prime when k is odd. Okay. When k is odd, k even के साथ this number will not give you prime. So k must be odd. So k is odd. Okay. So you see here 6 into k plus 1 and k is your odd. Odd plus 1 equal to even means k plus 1 even number. Okay. So even can be written as 2 times of some m or some 6 hai. So 2 into 3. Okay. M is here 3. So to this k plus 1 is even means it is 2 times of some integer. So 6 into 2 into m means 12 into m. This means 12 divides p plus q. This is p plus q is equal to 12 into some integer. So 12 is a factor. So therefore 12 divides p plus q. Similarly here it is also for when you take q equal to 3k plus 1 like this, p and q are integers. Okay. So this will give again 12 into m. So in all cases you are getting 12 into some p plus q equal to 12 into some integer. This means 12 divides p plus q. So if n greater than 9, then show that p n greater than 2n plus 3. Okay. These are small results but very interesting. We will prove it by mathematical induction for n equal to 9 because n greater than equal to 9. So for n equal to 9, p9 equal to 23 and 2n plus 3 equal to 2 into 9, 18, 18 plus 3 equal to 21. Okay. So therefore 2n plus 3, 21 and p9, 23. So in this case, pn, you see pn greater than 2n plus 3 for n equal to 9. It is true. We verified this. Now let it be true for n equal to m, that is pm greater than 2m plus 3. Now we need to show that pm plus 1 greater than 2m plus 1, 2 times of m plus 1 plus 3. Okay, for m plus 1 we need to know that 2 for m plus 1 strictly greater than. Okay. So this is pm plus 1 greater than equal to pm plus 2, since difference between two consecutive primes is at least 2. Okay, since difference between two consecutive primes is at least 2. Okay, so therefore pm plus 1 greater than equal to pm plus 2. Then this is strictly greater than 2m plus 2m. You see pm greater than here, this quantity pm is strictly greater than this. Okay, so this quantity is strictly greater than 2m plus 3 plus 2. And now calculating 2m plus 2 means 2 times of m plus 1 plus 3. Okay, so therefore pm plus 1 strictly greater than 2 times of m plus 1 3. So here you see m plus 1, here it is m plus 1. So this means we suppose it is for n equal to n, and here we prove it n equal to, for n की जगह देखिए m plus 1. Okay, so therefore by induction this shows that result is true for n equal to m plus 1, hence completes this proof. छोटे छोटे रिजल्ट है ये, होम असाइनमेंट है, देख लीजिए. n greater than show that pn strictly greater than n plus 2. Okay, now fundamental theorem of arithmetics. Okay, every positive integer we can cover maybe every positive integer, fundamental theorem of arithmetic. Okay, every positive integer n greater than 1 can be expressed as a product of primes. This representation is unique apart from the order in which the factors occur. So either n is prime or it is composite number. कोई भी नंबर है आपके पास n greater than 1. दो ऑप्शन है, either it is composite number or it is a prime number. Okay, if n is prime, then there is nothing to prove. Okay, if n is composite, then there exists integer d satisfying d divides n, and in the condition 1 divides d. By that theorem, the composite number के जो smallest divisor है वो d. So among all such integers d, choose p1 to be the smallest one. Okay, among all such integers d, choose p1 to be the smallest one. This is possible by well ordering principle. Then p1 must be prime as smallest divisor of a composite number is prime. So n equal to p1 into some n1. Okay, p1 divides n. So a p1 n equal to p1 into some n1. 1 less than, strictly less than n1 and strictly less than n. Similarly, if n1 is prime, then we are done. कैसे done देखिए, how p1 is prime और n1 को भी आप prime ले लेंगे तो it is a prime and it is a prime, so n can be written as a product of primes. Okay, so if n1 is prime, then we are done. If n1 is composite, then n1 equal to some p2 into n2, and therefore n ultimately n becomes p1 into p2 into n2. 1 less than equal to n2 less than n1. If n2 is prime, then we are done because तीनों product prime के product हो जाएंगे. Otherwise n2 equal to, otherwise n2 composite, इसका मतलब n2 equal to some p3 into n3 this, and similarly n equal to p1 p2 p3 and into n3. So the decreasing sequence n greater than n1, n greater than n1, n1 greater than n2, like this. Okay, well, cannot continue indefinitely. So after a finite number of steps, we get n equal to n1 into n2 into p3 into up to dash dash pk, where all pi are primes. क्योंकि आपके पास नंबर है वो कोई फाइनाइट नंबर है, इनफाइनाइट नंबर तो है नहीं. कोई नंबर आपके पास फाइनाइट है तो उसको आप ऐसे इनफाइनाइट नंबर ऑफ प्राइम्स में नहीं जा सकते, कहीं ना कहीं जाके आपको रुकना है. यू हैव टू स्टॉप एंड दिस इज एंड अल्टीमेटली लास्ट वन यू विल गेट. So prime, like this way you are getting prime, and the final one is also prime when you stop. So where all pi's are primes. So क्या हुआ ultimately, if n greater than 1 is an integer, okay, then it can be written as a product of primes. This is what called fundamental theorem of arithmetic. अब इसे uniqueness, आपको सपोज इसमें दो रिप्रेजेंटेशन आपने लेट n इक्वल टू p1 p2 pr and q1 q2 qs. सपोज r strictly less than s, कोई दो डिफरेंट where pi qi are all primes in increasing order. ओके, सब प्राइम्स हैं, बट यहाँ r प्राइम्स है और यहाँ s प्राइम्स है, s नंबर ऑफ प्राइम्स और यहाँ r नंबर ऑफ प्राइम्स. मान लो 10 है और 12 है, एक आपने कहा एक रिप्रेजेंटेशन 10 प्राइम्स के प्रोडक्ट है और एक रिप्रेजेंटेशन 12 प्राइम्स के प्रोडक्ट है, देन व्हाट इज द प्रॉब्लम यू सी. Okay, so or that is p1 less than, and these are the orders because increasing order में आपने लिया एक के बाद एक प्राइम आप 2 3 जैसे 5, okay 7 11 like this. So since p1 divides q1 q2 qs, p1 is a factor of this, so p1 divides q1 q2, there exists some qk, there exists, you see from here p1 is a factor of this. Okay, so such that p1 equal to qk, but p1 and qk are both primes, therefore p1 equal to qk. We arrange qi such that p1 equal to q1. इसी तरह का आप एक एक करके कैंसिल करते रहिए. You cancel out one by one. Here you cancel p1 and here you cancel, मतलब it is some qk, so we arrange some qi such that p1 equal to q1. We take k equal to 1. Okay, suppose it is q1. So p1 cancel and here it is q1 cancel, and इसी तरह का now p2 is a, we continue in this way, p2 is a divisor of this. Okay, so p2 इनमें से किसी एक के बराबर है, q3 q4 हमने for our choice p2 equal to q2, जो भी है उसका नाम q2 रख दिया. Okay, so this two cancel, p2 q2 cancel. Similarly you will, so here you take r strictly less than n. इसका मतलब when you यहाँ r कैंसिल कर देंगे तो यहाँ आपके क्यू आर कैंसिल, ओके, पी आर के साथ क्यू आर कैंसिल, बट क्यू आर के बाद आपका नंबर है क्यू आर प्लस 1, क्यू आर प्लस 2, क्यू आर प्लस 3, लेकिन यहाँ कुछ है नहीं आपके पास, ओनली 1. सो दिस विल बिकम 1 इक्वल टू क्यू आर प्लस 1, क्यू आर प्लस 2 अप टू डॉट डॉट क्यू एस, बट इट इज नॉट पॉसिबल एज क्यू आईज आर प्राइम्स, देयरफॉर आर कैन नॉट लेस देन एस. इसका मतलब आपको एक कॉन्ट्रडिक्शन मिला है, ऐसा नहीं हो सकता कि इधर 1 है और उधर कुछ प्राइम्स के प्रोडक्ट है, यहाँ आपको कॉन्ट्रडिक्शन मिल गया. 1 को यू कैन नॉट राइट 1 एज ए प्रोडक्ट ऑफ प्राइम्स. 2 into 3 एटलीस्ट 2 into 3 6 हो जाएगा. 1 कैन नॉट बी रिटन एज 6. ओके, सो 1 कैन नॉट बी रिटन एज ए प्रोडक्ट ऑफ प्राइम्स. सो दिस इज अ कॉन्ट्रडिक्शन एंड हेंस ये प्रूफ हो गया कि r s से लेस नहीं हो सकता. r कैन नॉट लेस देन s. सिमिलरली वी कैन शो दैट s कैन नॉट बी लेस देन. सिमिलरली q कम लेके r ज्यादा लेके करके देखिए. ओके, हेंस r इक्वल टू s. और ये तो हम चल ही रहे, p1 बराबर q1, p2 बराबर q2, सब बराबर बराबर करके चल रहे हैं. यहाँ नंबरिंग ज्यादा हो रहा है तो वो हम कह रहे नहीं हो सकता है. इसका मतलब p1 बराबर q1, p2 बराबर q2, p3 बराबर q3, p10 इक्वल टू q10. तो हम तो 10 तक जा रहे हैं और साथ साथ एक एक को इक्वल वी आर शोइंग दैट इक्वल्स. ओके, सो इसका मतलब दोनों रिप्रेजेंटेशन अल्टीमेटली आपने क्या प्रूव किया है कि these two representations are equal, same number of product primes and same number of primes and also primes are same. Okay, means ये 2 है वहां 2 है, यहाँ 2 into 3 है वहां 2 into 3 है. These are same like this. So hence r equal to s and pi equal to qi for all i. तो यहाँ से क्या हुआ, all pi qi के बराबर है और दोनों के नंबर्स भी इक्वल है. जितना p नंबर से मतलब p10 है तो आप q भी 10 तक चल रहे हैं. So that the representation is unique. Okay, so this is what called very interesting result, fundamental theorem of arithmetic. इसको यूज करते हुए we will do some problems in the next class on the based of fundamental theorem of arithmetic. Okay.